vlog and chemistry vlog to my science world. Okay, going back to the discussion of the hydrogen peroxide, and I'm done, and we are done with oxidation state and oxidation number determination. Now we go to question number 4. I don't put numbers, but actually it should be in chronological order. Okay, that's question number 4 here at the bottom part of the whiteboard. Can you see? Can you see vividly? Wow, vividly talaga. Okay. Alright, can you see clearly? Okay. And then 4, 5, 6. Okay, ganon. Number 4, explain. This is an essay type of question na talaga siya. Okay? Because in classroom structure, for example, usually happening in the final exam. Okay? Usually. It will never come out most of the times in the prelims or in the midterms. Sometimes midterms also have essays. It depends on the ability and the type of professors, teachers, instructors you have. Okay? In school and in classroom instruction. Okay? But this essay will not be lost, always there. This is to measure how the students understand comprehensively the subject matter or the topic. Okay? So this really apply critical thinking. You know, critical thinking, meaning the word why will always have in the brain cells. Why, why? Like that. So this is very important in determining if you try to discuss this in analogy to safety, it's used in root cause analysis. Always why, and then if the why will be consumed all, and that is the best root cause. Something like that. So it's also applied here in chemistry. Okay? This is a question. Okay, now explain why water is more stable than hydrogen peroxide after adding hydrogen gas and oxygen gas. Guys, many science students or almost students in the universities, in the institutions, or in the academic institutions learn, especially in the topic of chemistry, okay, so learn that the product of combining hydrogen gas and oxygen gas is always water, right? And there's no question about that. But this has also a rare situation, okay? Rare scenario wherein you add hydrogen gas plus oxygen gas, it will produce hydrogen peroxide. Okay? And this is not common na talaga siya. Only if you know this, chemical engineering students, this chemistry students, or any, engineering students or science students that possess a high ability of independent research. Independent research meaning he will extend his study or her study outside from the classroom instruction because he or she will not be satisfied. Something like that. Okay? So that's the ability. That's why some know, some didn't know. So actually, it's not the same. Okay? Like that. Now, so if I will put the reaction H2, this is not chemical reaction. I have to explain why it produces hydrogen peroxide and why it will produce water. Okay? First, we need to consider water because this is a very common. Without water, everybody will die. That's why water is life. Everything is governed by water. 75% of the planet Earth is composed of water body surfaces. The lake, the ocean, like that, the river, the creek, name it. Okay, the ocean, blah, 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 lake. Okay, the sea or whatever. Okay, so 75%, just like the human being also. We are composed of too much liquid rather than the solid substances we normally intake in our body. So this is very important. Okay, so H2 plus O2. See, I put 2 na because we are now dealing with chemical reaction. H2 plus O2 is equals to water. Take note, guys, hydrogen is a pure element. Oxygen is a pure element, specifically a pure gas. Specifically a pure gas also an oxygen. So these are under the study of the pure substance in the classification of matter. Okay. Now, if you combine that, it will produce water. And water now is molecule. So this is a study of the mixture na. And there are also classification of matter. Something like that, okay? Blah, blah, blah. Okay? Now, nakakaloka. Okay, so balance the chemical reaction. This is the second step. Balance the chemical reaction. So we can balance it by visual inspection or by the algebraic expression as per the law of conservation of mass in chemistry. Okay, the theory that states according to the chemistry that matter can neither be created nor can be destroyed by ordinary chemical means. Okay, what does it mean? So there will be no changes if you will never do chemical reactions or any other actions that involve operating conditions such as increasing the heat, okay, increasing the temperature, adding a catalyst, or adding an inhibitor to reduce the rate of the reaction, something like that. So you will always apply that. Okay, any kinds of external energy you will be able to put. So that's the time matter will change. And there's a chemical change or either a physical change. Boiling point, melting point, freezing point is a physical change also. So that is the law of conservation of matter. And after that, we have also the law of conservation of mass derived from that. Now dealing with a particle, with a molecule, an atom, or a mole. But basically, we are referring to the number of atoms because in the theory and concept, we are dealing with the balance of the atoms, not the balance of molecule, take note, not balance also of the mole. It's the balance of the atoms we are referring. That's why some students, including me before, will confuse because we are not understanding clearly what we are trying to balance. It's the number of atoms that we are trying to balance, not the number of moles, not the number of a molecule. Okay? Nor, it's not also the number of specific amount of measurement, which is the volume, the mass, or whatever, or the density. It's not like that. It's always the total number of atoms in the reactant must always be equal of the total number of atoms in the product. And this is the law of conservation of mass. Okay, and you will say also, why it's mass, Sir Sotero, not an atom? Because the mass is the common measure in stoichiometric relationship when you talk about a mass in relationship na in a chemical reaction. But the M, the number of mole, is the basic unit of the amount of substance, okay, when you talk about individuality, not only for the chemical reaction or stoichiometric relationship. Individuality meaning kasi, I have 2 moles of, sugar. Not necessarily I undergo chemical reaction. Not necessarily I burn the sugar. Or by sugar itself only, how many moles for this, like this. But when we apply the mass, okay, most of the times we will heat the sugar and produce carbon atoms and releases the hydrogen and oxygen because it's composed of carbon, hydrogen, and oxygen, right? So exothermic reaction. Okay, adding heat, and then they'll be producing carbon atom, the black color, and then the gases will be going to the atmosphere. Okay, or evaporated, something like that. You got the point? So that's it. So there's a little bit difference when we can apply the number of moles and the mass. That's why we always say law of conservation of mass, though we are dealing the atoms to be balanced. Something like that. Okay, you got the point? Maybe we'll also interpret that the total number of mass in the reactant is equal to the total number of mass of the product, which is not. So this is also another trick theory in chemistry. Because our title is the law of conservation of mass, then why our chemists before, or scientists chemists before, are trying to express the balancing of the atoms? It's not the mass, right? So sometimes, oh my gosh, you will not be dependent also with the word alone. So it's just like this. You have to have a critical thinking and wild imagination to become a scientist and to become an engineer. Okay? Because it's not limited only in the books. Sometimes you need, just like me before, this is not an arrogant, but I have to tell you the truth. During the actual examination, in the last day, I've made my own formulas. Because I'll never see this kind of problems before in my 5 years of study in BS Chemical Engineering in Cebu Institute of Technology University. I found it very, very difficult and I almost remembered everything what I studied and I cannot find a specific formula for that. And then I correlate and link every formulas I memorized starting from first year college to fifth year college. And I can come up with one derived formula by myself alone at that time. Sariling sikap. Because, what yung ko kayo nung gitudlo siya, guys. Siguro gitudlo siya, pero wala na ako ma-absorb. But you know, I was really shocked at that moment. And I created my own derived formula and equation that is chemical engineering on the third day. Okay, the very long paragraph, something like that. And then it took me a very long time because I solved that last. Okay, I solved that last out of, let's say, 400 plus questions, something like that. Right, 400 plus meaning 100 general engineering, 100 plus engineering, 100 plus physical and chemical principles, 100 plus chemical engineering. I total that one, that's why 400 plus questions, theories, and problem solving. Now, siguro stuck ako, guys. Okay? I really computed well. I take my time. And so, like our, engineering head, the chemical engineering is not engineer Mamano, shout out. He was there, very supportive to us in the venue. That's in Cebu City. Oh my gosh, I'm the last in the venue to go out. Oh my gosh, wala na mga ubang examinees sa akong kilid. Oh my gosh, ako na nabilin. Okay, because I need to solve that really. Okay, when I go out in the room, the mami said to me, so kaya mo siyang kitikti. Ako dyan ko nung kitikti. Kung mamilisod mong good kayo, ma'am, ang ganan. Okay, so I don't think so it's correct, and I don't think so it's wrong, but at least I've tried my best to make my own derived formulas and equations so that I can solve what is being asked in that particular question. Ganon. Okay, going back to the topic. So H2 gas, hydrogen gas plus oxygen gas is equal to hydrogen. Water lang sa top, balance. Okay, so two ways, visual and algebraic expression in math. Okay, so hydrogen 2, oxygen 2. So there's no oxygen 2 in the product, and we have to put 2 here. So 4 hydrogen, put 2 here. So 4 hydrogen, oxygen 2, oxygen 2. Balance. So 2 moles of hydrogen gas, let's do it in this way, plus 1 mole of oxygen gas is equal to 2 molecules of water. Because that is already compound. Okay, but I think it's still applicable, but that's what I've learned in my research. That it will not, because I research most of the times, because what I learned also, you can call this also as atoms of water. But actually, really, the technical way of saying that, or to be precise and accurate, that is 2 molecules of a compound water. Because water is already a compound, composed of a molecules, not mole already. You get the point? So this is 2 molecules of water, not 2 moles of water, because there's a difference between a mole and a molecule. A molecule is larger unit composed of several atoms. But a mole is just only a unit of measure of the amount of substance. Could either be single, stand alone, just like the elements and metals. So you will say that it is a mole. Okay, something like that. And then if you multiply that with a subscript, it will become an atom. So there's a difference, right? So you will never call that an atom if you will not multiply that with a subscript. For example, H2. Okay, I will say 1 mole of H2. Okay, and I will say 2 atoms of H2. But I will never say 1 molecule of H2. Because H2 is not a compound, guys. You get the point? It's still a pure element or a pure gas, hydrogen, which is the lightest gas in the planet Earth and in the universe. You get the point? Discovered by Henry Cavendish. Okay, it's very clear. Lightest talaga siya. The second lightest is helium. Okay, so these are the most components of the Proxima Centauri, which is the Sun, the scientific name of Sun. Okay, S-U-N. Okay, now this is the balance equation of producing 2 molecules of water. Okay, case 1. Case 2. Adding hydrogen and oxygen also will produce hydrogen peroxide. So H2 plus O2 is equals to H2O2. Then balance the chemical equation by visual inspection. So hydrogen 2, oxygen 2. Perfect! We don't have to put 2, we don't have to adjust by putting alone the elemental constituents, then bingo, balance already. So in terms of balancing, we will be happy to do the second case, which is the hydrogen peroxide product chemical reaction. Rather than the water, because the water we need to add 2 like this, blah blah blah. Okay, now the question is, which is more stable? The hydrogen peroxide or the water? What comes on your mind when we talk of stability? Again, English. In English, in the interpretation, in the comprehension leveling, you start with English. Okay? Sometimes, even though how good you are in math and in science, but the requirement really is you are good in English first. Okay, the vocabulary, the terminology, the synonyms, the antonyms, the homonyms, name it, punctuation marks, preposition, pronoun, adverb, nouns, collective, pronoun, adjective, and everything. Okay? Or prepositions, you should know that category so that you can understand how to interpret the paragraph and the sentence in the questions. Okay? So that's really the requirement. So I'm always telling you guys, it's not really a requirement to be good all the time in math and science. At least you will be also good in English. And balance only in math and science average. Average among the 3. Okay? Not really that superior in mental ability. Though it's an advantage, but God did not give us equal higher intelligence level. Let's accept that fact. Okay? Some are super genius and some are not. Okay? Some have higher IQ and some are not. Some can have a very good English communication skills, but others cannot. So it's a gift from God given to us. Then we cannot force that. We should have that all the time for us. Because we are not the same. We are considered unique. We have individuality, uniqueness among the other. Okay? If I have this, I don't have also the other skills and talents. It's gonna be like that. And it's accepted fact. Okay, so their weaknesses, those will be my strengths. Okay, my strengths, those will be their weaknesses, something like that. So we cannot really, equalize or put into equilibrium or our talents and skills and abilities. So that's why I told you, it would be better at least you are average in math, science, and English. And other subjects will just go over the flow. Okay? You get the point? Because international language is English. Then you can really interpret, especially if you're working in an international, multinational companies in the future. Okay? You get the point? Okay, going back to this balancing of chemical equations. Guys, in the question so far, the communication is very fast, right? Sometimes you cannot understand. My tongue. That's my weakness, really. I talk very fast. Okay, so forgive me. Okay, going back to case 1 to case 2. Now, the problem says which among them are more stable. Okay, stable. The stability. Okay, stability meaning you are talking about the reactivity. Right? So when you speak about the reactivity, you are talking about the chemical changes involved in a chemical reaction. As simple as that. Okay, there's a change. Because the definition of chemistry is a branch of science that deals with the study of matter, which are specifically solid, liquid, and a gas, and the changes it undergoes, meaning could either be a physical change and a chemical change. And this chemical change are purely involved chemical reactions and also chemical bonding. And that's very clear. Okay, so reactivity, so chemical reaction and stability is just the same. Now, let's talk about these two chemical reactions here. And now we will remember what are the kinds of reaction and what are the types of reaction. So that we can equate the stability terminology in that aspect. Okay, because we are dealing with chemical reaction, how it will react. Could it be stable or not? Could it be artificial or natural? Could it be spontaneous or reversible? Something like that. Okay, now, question and case 1. Water. Okay, because our question here is very clear. We need to determine which is more stable. Okay, like that. Okay, how can we determine the stability in correlation to how reversible the chemical reaction really is, or how irreversible the chemical reaction, sorry, stop it, and how spontaneous the chemical really is, and how non-spontaneous the chemical really is. The one technique I will be able to teach you guys is that if it is more stable, it will undergo spontaneity of the chemical reaction, or the reversibility of the chemical reaction, meaning those chemical reactions that involve spontaneous chemical reaction and reversible. What does mean? It will goes back to its natural reaction even if you will not apply internal energies or external energies or any chemical means or operation separation processes or whatever. Okay, there's no changes. Normal or natural lang siya. Okay, when we drink water and when we boil water, it will just disappear. Okay, even though you will not heat that one, the water will be vaporizing slowly, gradually in the atmosphere. Because water also has the characteristic of volatility. It will just vaporize into the atmosphere little by little. That's why the moisture will come. Okay, and then it will become little by little, the volume will decrease. And you just don't know that because there's a radiation, okay, in the atmosphere. There's a heat transfer also in the environment. Okay, so volatilize ang water, guys. Okay, that's natural na siya. So that's the measure of spontaneity, and reversibility of a chemical reaction without doing anything. Now, in case of water, okay, I will teach you. In case of water, though it will go back to its reactant or not? In case of water. Okay, obviously it will goes back. Okay, because this is natural process. Chemical reaction that God gave to us. Doesn't involve cost in changing the chemical reaction. As long as we have the light of the sun, then it will just, split the hydrogen to oxygen, the water into hydrogen and oxygen, and again go back to a water molecule again. That's why we drink the water and we use the water in the process, something like that. Blah blah blah. So that's really natural and spontaneous and reversible. Okay, we know that already in water. So it will become now, at siyang balingon, it will now become 2 moles of water is equal to 2H2 plus oxygen gas. In chemistry, when we say reversible, we need to put arrows. Arrows going to the right and arrow going to the left, just like this. Symbol like that. And this is showing the reversibility and the spontaneity. Actually, guys, the spontaneity and the reversibility, or the spontaneous chemical reaction and reversible chemical is just the same in concept, but it depends on the context and subject matter. Spontaneous usually applied in the physical chemistry, physical chemistry that undergoes physical changes most of the times, right? And it's stoichiometric relationships in there. But when we speak of reversible, that's usually applied in general chemistry, the general. That's why I say always spontaneous and reversible, because it is tantamount with each other, or equal in degree, something like that, or synonym with each other, meaning the same, similar, okay, like that. So this is also spontaneous chemical reaction, and this is also reversible chemical reaction. So we have now already a clue that this is more stable than hydrogen peroxide. Now, for the purpose of discussion, I must also reverse the hydrogen peroxide. Just to say, if it is also a spontaneous chemical reaction or reversible chemical reaction, how stable is that? When I reverse the hydrogen peroxide, I say H2O2, okay. You expect a product also which is RH2 and O2, but no, it's not. It will produce now water and oxygen gas. Okay, so it's very clear that hydrogen peroxide is not reversible chemical reaction. It's not spontaneous chemical reaction. Let's say if you try to calculate the Gibbs free energy for this, because it gives free energy in physical chemistry, because the more you obtain a negative G, the more it is spontaneous, right, in physical chemistry. So to those who take up base chemical engineering, right, so that is Gibbs free energy, and we take into account the entropy and the internal energy, right? something like that. So it's gonna be gas-free energy based on my memorization is equal to the change in internal energy minus the temperature times the entropy. Okay? So if you try to substitute values, if it's a negative, then it's also something, yeah. But we don't have to deal with that. It's more complicated, right? So H2O2 is equal to water plus oxygen. Guys, I forget to tell you also, if you try to involve, if you are really concerned to the phase of the matter, PHASE, phase or form of the matter or states of the matter, it's just the same, synonymous, right? Okay, we are very, very concerned to the phase. We need to put symbol. For example, water will become liquid, small l. Oxygen will become gas, like that. But for the purpose only of calculating the amount of the stoichiometric relationship, let's say the volume, the mass, the density, the viscosity, and then the molar expression, we are not concerned to the phase already. We will just balance that without stating the liquid. Okay? But in here, we need to do that because we are always looking at the spontaneity and reversibility of the chemical reaction. So starting from a liquid hydrogen peroxide, small letter L, okay, it will split up to, okay, water liquid and oxygen gas. Now, this oxygen will have the arrow up. In chemistry, the arrow up means it will vaporize or evaporate into the atmosphere, something like that. And arrow down would mean a solid, but that is not usually expressed. It will just put small letter S in the solid and liquid small letter L, like that. Especially if you're dealing with physical change, not chemical change, because the phase is very important, right? From solid to liquid. Mga ganon siya, boiling point, mga ganon, freezing point, like that, chuba-chuchu, distillation, extraction, okay, sedimentation, centrifugation, flotation, leaching, like that, okay, absorption, like that. You get the point? Mga physical separation processes or unit operations, right? Because if we speak unit processes, that's more on chemical separation processes. But if we speak of unit operation, that we mean more on the physical aspect, not really involves chemical reaction. Okay, for example, distillation is just only a separation in terms of the boiling point. Okay, we don't have a lot of chemical reaction there. We don't add catalyst. Like that is simply distillation, like that. Boiling points differences lang talaga siya ang atong basis of separation. Okay? That's why it falls on the physical chemistry, meaning physical properties of matter. Okay? Like that. Now, so muna niyo siya. Okay, this is hydrogen peroxide. So what ang product? Water plus oxygen gas. So, this is unstable. Because it will never go back again to its original form. It will alter and change and produce another product or same products in a combination of another product, which is compound, element, blah, blah, blah. So that's what it means of a irreversible chemical reaction and non-spontaneous chemical reaction, tantamount to the instability, okay, or not reactive that much or unstable. Okay, so that's why we say that is a question. The answer will be, okay, water is more stable than hydrogen peroxide upon adding hydrogen gas oxygen gas because this water product is undergoing a natural process which is a spontaneous chemical reaction and reversible reaction, and it will go back to its original reactant and then go back again to its product, blah, 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 so and so. And the other one is hydrogen peroxide will never go back. It's up to you to make the statements as long as the point has been extracted already. And it's also a big point. It's not really the English that matters. The main point you are trying to write in your answer. You get the point? Like that. Since that is an essay, it doesn't mean that you are straight to the point or direct. Because if you try to be straight, point, and direct, your words are very limited. Okay? Now, in essay, as long as you can support any reasons or logic reasons, then put that there. Because that is part of the explanation of that particular question. Then if you just put one sentence, two sentences, though you get the main point, like that, some instructors will not give a very big points for that because it's only small. Because there's still another supportive theories and concepts behind that needs to be supported in your answer. So meaning to say, in an essay question, you don't mean to always to be straightforward in your answer. As much as you could, you should be detailed and comprehensive so that the chance is you get a higher points compared to saying it directly. Because if you say it directly, go directly to the point, you're just referring to the technical directly. There's no supporting theories behind that. But some instructors really would try to measure why. Okay? Why? Then you have to support, you have to back up. Just like, filing a case in the law, in the Supreme Court or whatever, you need a lot of supporting documents to validate, okay, to validate your complaints. Okay, so that you have a solid proofs and evidences so that the case will push through. Or else, it need to be validated very well. So many times, if there's only a very few supporting documents, so they will say, this is basura, something like that. So, just like that also in essay questions. Okay? You get the point? So, as much as you could, answer it in a straightforward manner first, and then make it detailed and comprehensive if that question is essay. Okay, 50 points, ganon. Okay, 40 points, ganon. Oh, if you're an instructor, you will never like us to put 50 points and they are only stating one sentence. You get the point? So it should be comprehensive and detailed. Okay? But the main point should be there. Okay? So that's it. Maybe they will give 50 points, like that, 40 points or whatever. Okay, now, we go now to, nakasabot na tayo, pero ato kan i-balance ang hydrogen peroxide, guys. And if we balance the hydrogen peroxide, I think this is the most unique balanced chemical reaction all over the world. Ako talaga yung research. Okay, so there's a lot of chemical reactions, in the planet Earth and in the universe. There's trillions and trillions chemical reaction. Okay, and we cannot memorize everything. And we found out that this hydrogen peroxide is the exemption in following the algebraic way of balancing. Okay, opposing and in contrary to other chemical reactions that following really the algebraic expression of balancing. Because there are two ways how to balance the chemical equation. By visual inspection, trial and error method. Okay, you need to look at the right, you look to the left, and try to put numbers so that it will be equal, like that. And then you start the numbers from 1, 2, 3, 4, 5. The clue is start with a minimal number first. Okay, so that it will be simplified. Okay, that's the trial and error method. But the most accurate is the algebraic expression, letting the number of atoms unknown in the algebraic expression and the linear equation. That will be holds true in the law of conservation of mass. Almost everything except for this hydrogen peroxide, what I discovered. I already saw this last night. Okay, I really, how this behavior is all about, because I cannot sleep if I cannot solve something like that. If there's a problem that I cannot solve, I cannot sleep properly. Okay, then I investigate really the chemical reaction of hydrogen without looking first the Google search, because I'm not really that dependent on the Google search most of the times, unless I will make a procedure like that or whatever, or a safety inspection checklist. I have to refer to the Google search using first my knowledge, experience, something like that, and then go to the Google search. It's not really my top number one choice. Okay, because my mind will not be sharpened if always depending on the Google search, because I'm not used to do that. Okay, I'm only doing that after I have already my data in my sheet of paper. Then I'll just put some in the Google search to add more, of course, because that is www, which is better than me. But what I'm trying to say, me first before the Google search. Okay, something like that. So now, I solved that last night, this hydrogen peroxide. Okay, like that. I am in a pure silence. So if my room is in pure silence, muna na siya natabo. Okay? Like that. Okay. So akong i-investigate, guys, dili siya mo sarili ang katong algebraic expression. I'm not to show this to you. Later I will show, ha? and then mukhaon sa kuukuan kanang pan. For na after carbohydrates with empirical formula of CH2O, diba? Okay, now, kani siya guys, ako sa papasa guys ha. Okay, taas na juga akong kuan guys, may bilis saya na lang po in fairness. I love to talk in English and mix with Bisaya, okay? Like this. Okay, but sometimes, you know, even Bisaya, masapit talaga pa akong dila. Okay, but I'd rather to talk in English. Okay? You know, no, it's really sometimes, not all the times, because I'm a Cebuano, and sometimes also there are a deep Cebuano language also that I cannot really share to you. Okay? For example, kukabeldo, like that, alimpatakan. So there are also terms in Bisaya that you cannot understand also. Then, since my channel is universal, then I want also my audience to understand what I'm talking. Right? So this is academic information, not limited only to my native tongue or my national language, Tagalog, something like that. Or my dialect is Cebuano, right? So I would be at my best if I would talk in English, something like that. You get the point? Okay. My coffee is almost consumed. Because. Okay, now, ito na hunong guys. Okay. Now, hydrogen peroxide balancing. Let's do first the most easy, the trial and error method, in which most students are applying in our high school, first year college, or even in our grade school level, right? There's also elementary chemistry are already expressed there in the discussion, but not that detailed compared to high school and college, but it starts there. Again, because chemistry is a pure science, okay? We need to know this. Okay, because everything around us is a chemistry. Okay, from the moment we wake up, from the moment we sleep, okay, we will die without oxygen, like that, we will die without water, and this matter compounds are chemistry, okay, like that. So, going back. So, we have hydrogen peroxide as a liquid. Take a look at the whiteboard. Right? And then, or you can carry or bring like that a blank sheet of paper, and then try also to remember things that I explained to you, right? Okay, so H2O2. So hydrogen peroxide is a liquid. Okay, you're sure for that. Okay, liquid. And then it will decompose. Guys, in chemistry, the word decompose is under the decomposition chemical reaction, right? Splitting up of molecules from a compound. Right now, we will use the symbol like this, like a triangle. Okay, like that. Okay, since we know this is irreversible and spontaneous, we need to apply heat. Okay, unlike water, no need. It will just volatilize in the atmosphere. That's spontaneous. Okay, but in here, see, with the hydrogen peroxide liquid will break into water and oxygen gas. So the H2 gas is lost. So Mr. Martino, why the H2 gas is lost? And I cannot explain that because that is technical aspect derived or studied by our scientists before. Right? Especially the father of modern chemistry, Mr. Antoine Lavoisier. Okay? So I cannot investigate further for that. Okay? I'm just only knowing that this is gonna be the proper way of explaining something like that. So, natagak ni H2, no? Okay, it's completely the, distraction of the original reaction of H2 plus O2 is equal to hydrogen peroxide. Nakakatuwa. Okay, now, never mind the hydrogen gas. Okay, so the products now are molecule of a water and an atom of an oxygen. Something like that, okay? So how can we do this? Balance the chemical reaction now. Okay. Unahon ako ang visual inspection trial and error method because, as I said earlier, the algebraic expression of solving the atoms will not apply here. Okay? So I will say, okay, H2 balance. So 2 atoms of hydrogen here, 2 atoms of hydrogen here. So oxygen 2 in the reactant and oxygen 2 here also, 3 in the product. We have 1 atom in the water and 2 atoms in the oxygen. So to make it balance, guys, I need to make this 2 in the water, so 2 like that. So there are 4 oxygen now, and then we need also to balance again. We need to put 2 here, oxygen will become 4, and then the hydrogen is balanced already. So hydrogen 4, okay, oxygen is 4. So perfect, like that. The technique here, guys, we don't have to put an add mole. Add meaning in mathematics, add and even numbers. You remember that one? Add, ODD, meaning 3, 5, 7, 9, what else? Oh no, yes, like that, okay? And then even number 2, 4, 6, even numbers 8, 10. So your clue here, in this case, you will never go to the even add. Okay, because most of the time you will be tempted to put 3 first, like that, okay? And you will just put 2 para 4 siya. Okay, even. That's a technique here in hydrogen peroxide. Exemption ni siya, guys, ha? Okay, of all the chemical reactions, trillions of chemical reactions in our planet Earth. Okay, something like that. Now, balance na siya. Okay na. Let's use algebraic way expression of balancing. Kasi may tabo, akong papason. So the trial and error method and visual inspection is good in this case. And now we use the law of conservation of mass by using algebraic expression or linear expression way of solving the number of atoms. Okay? So, balik. H2O2, liquid, okay, is equals to water, liquid, plus oxygen gas will go up. The oxygen evaporates into the atmosphere, right? And we apply this heat, or the small triangle. Small triangle is the heat in chemistry, ha? Okay, you get the point. Okay, now. So, mamaya na ako, guys. Magbutong ko. Char! Okay, now going back. So, algebraic way of expression, balancing. Now, hydrogen first. Hydrogen 2 here, and hydrogen 2 balance ang hydrogen. And then oxygen 2 in the reactant. Guys, nalinaw mo? Okay, oxygen 2 ang atom sa reactant. And the product is 1 from oxygen, in the molecule of water, and 2 atoms in the oxygen solid. So 2. So 2 and 3 is not balanced. That's why it's balancing of the equation. You have to balance that one. Now we let X as the unknown atom of oxygen in the less atoms of oxygen. It's obviously in the left because there are 2 atoms in the left and 3 atoms in the right. So we will put X beside oxygen. Okay, we let that as an unknown atom. So X. Okay, algebraic expression. So subscript times coefficient, 2 times X. Equality sign meaning equilibrium of the chemical reaction, because we are referring the law of conservation of mass is always an equilibrium, applying the law of continuity at a steady state flow. Something like that. Okay, so here time is not an issue. Okay, time is independent. Okay, this is not the same with chemical reaction kinetics that consider time always in a rate of a chemical reaction. We're not talking yet of rate of chemical reaction. It's just chemical reaction. Okay, so 2x independent siya with time. Okay, so 2x is equals to 3. Okay, x is equals to 3 halves. Improper fraction because 3 in the numerator is higher than 2 in the denominator. Then we have to put the value of x beside oxygen, carry this there, so it will become, remove the x and put 3 halves. Okay, 3 halves. Now, erase your solution so that you can use another solutions later. Okay, now you have now 3 halves of a hydrogen peroxide molecule as a liquid heated up to produce water liquid plus oxygen gas. Since we have now a improper fraction, the rule in chemistry, we need to apply the algebra. We need to cancel the denominator of this 3 halves by multiplying both sides. We mean of both sides, reactant and the product, left and right. Okay, so multiply this all with 2 because this is the denominator. So 2, ganon. So 3 halves times 2. 2 will cancel this. So 3 Okay, 3 molecules of hydrogen peroxide liquid, okay, is equals to 2 molecules of water as a liquid also, plus 2 moles of oxygen gas. But anyhow, guys, you don't have to be particular. Huh? That's only my method. So for the purpose of discussion only, you can also say 3 moles of hydrogen peroxide, okay? Because that's what the teachers are taught us. I'm just telling you the accurate and technically precise, the most accurate to say it. Because if we have English grammar, we have also science grammar, or chemistry grammar, physics grammar, how to say, okay? You get the point, because it is a molecule of hydrogen peroxide. We will never say a mole. Okay? It's 3 molecules of hydrogen peroxide, not mole. But since we are practicing that in our education, that it's still also moles, then there's no issue. Okay? As long as it will balance. You get the point? Maybe it will become a question in the future also. The coefficient of water, what do you call this? A atom, B molecule, C particle, D nucleus, oh, nga. So that is a molecule already, not a mole. So ma-confuse ka kay your teachers, instructors, and mentors in your elementary and grade school level are always telling you that that is the number of mole beside the compound. So things like that ba? That's why sometimes also we need to discuss the accurateness and the technical preciseness of how to say terms in chemistry or in pure science. Okay, ganon. Okay, now we have 3 moles. Tawag na, see? Isipat sa akong baba, no? But for the, okay lang siya guys, ha? Forgive me, magpagawa na sa tag-moles, guys, because we are used to that na good. It's not easy to correct if you are using that for how many years? Okay, for example, I'm using this for 20 years plus in my BS Chemical Engineering study, something like that, and I will change that immediately to molecule. Of course, my tongue will slip. SLIP will sleep most of the time. So the purpose of discussion, let's agree that we will just say also moles. 3 moles of hydrogen peroxide is equal to 2 moles of water plus 2 moles of oxygen gas. Okay? Ay, nakakaloka. Okay, so hydrogen 6, hydrogen 4 is not balanced. Okay? That's very clear. Now, if that is not balanced, we have the 6 atoms of hydrogen in the left side. And we have 4 atoms of hydrogen in the right side. Now, deficient ang hydrogen atoms in the product. Now, let X beside water as your atoms of hydrogen in the product. Right? Because there's no H2. You get the point? So we have put X here. X. Ganon. So 6 is equals to 2 times X is equal to 2x, right? Like that. Okay. So, ganon. So, 4. Okay, ganon. So, asa man ka magbutang? Dili agay ka sa magbutang dyan ka kay sa compound. Okay? So, it's gonna be 2 times x plus, and we're dealing with hydrogen. So, this is 2 times x. And then this is 2 subscript. So, it will become 4. 2 times x is equals to 4x. Okay? And now, algebraic expression. Let's divide this with 4. Cancel. So this will become 6 over 4. X is equals to 6 over 4. And then in proper fraction, using the LCD, least common denominator in elementary level math or grade school math. So 6 divided by 2 is equals to 3 in the numerator and 2 also in the denominator. So it will become x is equals to 3 halves. Right? Ganon. Okay, hindi mo siya mabalance. 3 halves. Again, we need a 3 halves now. We have to put that there again and balance again the chemical reaction. Okay, now, okay, why I did this? Because 6 atoms lang ang sa PCAS and the other one is the 4 atoms in the PCAS. So, product. And that's why we need to put the X here in the deficient side. Okay? So I will put the 3 halves here now in the water. Remove the X, change with 3 halves. Okay. Erase the solution so that it will not, it will not make disturbance in your eyesight chart. Okay, so 3 moles, again, write it again. Nakita ninyo guys? Okay, so 3 moles of hydrogen peroxide liquid is equals to 3 halves times 2. Cancel the denominator. It will become 3 moles of water liquid. Right? Liquid. Okay. Plus 2 moles of oxygen. Okay. Balance the oxygen now because you balance the hydrogen kalas. Both have 6 atoms. Now, oxygen here in the left side, reactant is 6, equal to the oxygen in the molecule of water is 3, plus the oxygen in the oxygen soul of light as a pure element. So we have 4, so 7. So 6 is equals to 7. Now, the 6 is deficient. So you need to put X again. You let X, the number of atoms of oxygen, to balance the number of atoms in the product, which is 7. So you have to put the X here beside the hydrogen peroxide. Okay, now it will become again, remove the solution, and then do the math. Okay, so we have now, okay, like this, we have now 2 times 3. Okay, 2 times 3 for oxygen. 2 times 3 times x, this is 6x, equal to 7 on the left. So this will become 7 over 6. Improper fraction again. 7 is an odd number and 6 an even number. Okay, then we have the 7, 6. Put that in the x here because we have the value 7, 6. So we name 7, 6. 7 over 6 over 7 over 6. Now, do the math again. Okay, so 7 times 3 is 21 over 6 is equal to hydrogen peroxide liquid is equal to 3H2O of liquid plus 2 O2. Now, we have a proper fraction which is 21 over 6. Now, consider the least common denominator or LCD. If you found out it will be divisible by a certain number, that's the technique to simplify the figure of the fraction. Okay, it's in here 3, of course. 6 divided by 3 is 2. You have to put 2. 21 divided by 3 is equal to 7. So 7 halves na lang siya. So 7 halves hydrogen peroxide. Now there's still 2 in the denominator. Then by math, we need to multiply both sides by the denominator 2 to cancel that out because we don't have fraction in a chemical reaction. That's not allowed. Okay? That's the purpose behind. We use the math for this. Okay, so 2. So cancel the 2, it will become 7 moles of H2O2 liquid is equals to 2 times 3 is equals to 6 moles of water. Okay, liquid. Okay, plus 2 times 2 is 4 moles of oxygen gas. Now this will be our final in algebraic expression of solving the chemical reaction of hydrogen peroxide. Erase. Okay, ganon. Ito nag-i-erase mo na itong finality of the matter or the final and executory in Supreme Court so that there will be a conviction after. Okay, based on your complaints. Okay, muna siya ang final and executory. Okay, we have 7 H2O2 liquid charara is equals to 6 H2O liquid plus 4O2. Now, is this balance? Okay, 14 hydrogen, 12 hydrogen is not balance. Hala. Oxygen, 14. Oxygen 6 plus 8. Balance. So, you will say, hala, because the more you keep on doing the algebraic expression, the more the coefficient will become higher. And you'll always find what numbers will be the less common denominator. So it's not practical already. Okay, you get the point? And then the last option, okay, the last option is you need to retrieve back the number of atoms that you release into the atmosphere. Let's say lang hypothetical theory and concept. Meaning, I do my wild imagination for a moment just to balance. the equation. Though it's not subject to reality, but I do it for the purpose just to balance hypothetically. Hypothetical meaning not in reality. For the purpose of discussion. Let's say I retrieve and I recover the hydrogen gas in the atmosphere to be back in the product of my chemical reaction just for the purpose to balance the chemical reaction. It's possible. I'm not telling you this is correct. I'm only just trying or assumption. Okay? So I have to put H2 again. Okay? Now, we need to balance again the equation. So 14 hydrogen, 12 hydrogen, and we add H2 in which we recover that from the atmosphere. Actually, it's released that before, right? So, it will balance na siya. Okay, but take note, we add H2 to balance the chemical equation in which it violates the principles and concepts of how to balance the chemical reaction. So, it's not that way. Okay, just only using that wild imagination. As I told you, to become a scientist and engineer, you have a wild imagination or critical thinking. Now, emotion pwede i-maximize all the formulas and equations comes in your brain cells, correlate, learn, something like that, derive, so that you can come up with your own formula. It's gonna be like that, not limited in the classroom instruction, as I always told you every time for that. Okay, now, this is incorrect because we will never recover and get back the hydrogen atom that's released in the atmosphere just to balance the chemical equation. Okay, now this is wrong. We need to use the first one, the simplest one, in which H2O2 liquid is equals to water liquid plus oxygen gas. Okay, 2 moles of water and 2 moles of water, 4 hydrogen, 4 moles of oxygen, balance, perfect galore. Okay, like that. So it's gonna be the perfect decomposition reaction of hydrogen peroxide is 2 molecules of water liquid will decompose into 2 molecules of water liquid plus 1 mole of oxygen gas. Okay? Like that. It's not based on algebra. Only siya akong na-discover. Okay? Of all the chemical reactions I encountered, starting from the grade school level until now. Oh my gosh, grabe no? Nakakaloka. Okay? So, muna siya guys. So again, if we add hydrogen gas and oxygen gas, there are 2 chemical reactions involved, producing a water and producing an hydrogen peroxide. We will not usually use the hydrogen peroxide, though it is applicable in the process, of course, in the production of hydrogen peroxide business, of course. Okay? But the water is the most stable because that involves spontaneous and reversible chemical reaction, stable, without adding any internal and external energies, and without adding any physical and chemical changes in it. Natural process. It will goes back to its original form, an original reactant. And this hydrogen peroxide will no longer back to its original reactant because this kind of chemical reaction is non-spontaneous chemical reaction and irreversible chemical reaction. And I thank you. Thank you so much for watching this video. It took me a long time to discuss, right? If you like this video, you can comment and like and share, and then you can subscribe to my channel if you want to, and then you can click the notification bell for some news updates about the senior, HNFOS, your YouTube content creator, science blogger. Thank you so much. Bye-bye, everybody. Kaloka. Ang haba Nakakaloka ka dyan. Okay guys. Ganon.